While the battlefield map in Ukraine has changed very little, a different reality is unfolding at an increasingly alarming pace. Russia is losing manpower on a large monthly scale, not in decisive battles, but through activities that appear routine in modern warfare. In areas such as the Zaporizhia to Huliaipole axis, fighting does not erupt in dramatic breakthroughs, yet attrition pressure is applied continuously and systematically. Russian infantry units are detected early, infiltration attempts are broken before they fully form, and supply routes become targets from the preparation stage onward. These losses are not caused by a single weapon system. They result from a combination of UAVs, precision fire, and unmanned ground vehicles working together. The battlefield is operating under a new logic, where human soldiers are pushed farther from the most dangerous zones, while machines take on the role of applying pressure and controlling combat tempo. The central question is no longer who is advancing on the map, but who can endure longer in a technology-driven war of attrition, where every movement carries a cost. Join military force as we take a closer look. The war in Ukraine is no longer focused on breaking defensive lines, but on steadily draining Russian manpower and operational tempo over time. Rather than pushing for dramatic territorial gains, Ukrainian forces are shaping conditions where Russian units lose people, equipment, and momentum simply by trying to operate. Success is no longer measured by how far the front line moves, but by how much pressure Russia must absorb to keep units active at all. This shift is especially visible along the Zaporizhia to Huliaipole axis, which has emerged as one of the most demanding sectors on the southern front. Here, fighting is not defined by large armored thrusts, but by constant infantry contact, repeated probing attacks, and close combat in damaged urban areas. Small engagements occur daily, often inside streets, tree lines, and partially destroyed buildings, where exposure is high and mistakes are costly. Under these conditions, Russia has been forced to change how it attacks. Large mechanized assaults have become rare, replaced by small infantry groups sent forward to test Ukrainian positions and search for weak points. This approach reflects limitation rather than choice, because armored vehicles are increasingly detected early and struck before they can shape the fight. The outcome is a pattern of losses that remains high even without major offensives. Russian casualties in this sector accumulate through constant movement, failed infiltration, and repeated withdrawals, creating steady manpower erosion instead of short spikes tied to single battles. This steady drain is not accidental, but the result of a battlefield environment dominated by UAVs and aerial sensors. Persistent surveillance from above now defines which routes are usable, which positions are survivable, and which movements trigger immediate response. Roads, open ground, and even temporary cover have become exposure zones rather than safe passage. In this environment, detection often matters more than firepower. Once a unit is seen, it can be fixed in place, delayed, or targeted without requiring direct contact. Russian infantry groups are frequently disrupted before they reach assembly points, while support elements struggle to move without drawing attention. As a result, attrition becomes systematic rather than situational. Losses do not depend on dramatic clashes, but on repeated exposure over time, which wears down units through fatigue, reduced cohesion, and slower rotation cycles. The pressure builds quietly, but it compounds with each failed attempt to move or regroup. This model changes how the war is fought and how outcomes are calculated. Territory becomes secondary to endurance, and the ability to sustain presence matters more than momentary advances. For Russia, this means paying a continuous price simply to remain on the battlefield. It is from this attrition-driven environment that Ukraine begins to translate battlefield pressure into concrete casualty objectives, turning persistent contact into something that can be measured, tracked, and planned. Ukraine's stated goal of inflicting 35,000 to 50,000 Russian casualties per month is framed as an operational benchmark rather than political messaging. The figure is not used to claim victory or boost morale. but to define the level of pressure needed to weaken Russia's ability to sustain combat operations. In this model, success is measured by whether Russian units can continue rotating, regrouping, and launching attacks under constant strain. This approach reflects a broader shift in how modern wars are planned. Instead of seeking decisive battles, Ukrainian planners treat manpower loss as a cumulative effect that can be shaped and maintained over time. The objective is not sudden collapse, but steady erosion that reduces Russia's ability to function as a coherent fighting force. The scale of this target becomes clearer when placed against Russia's military history. During the Soviet war in Afghanistan, roughly 15,000 personnel were lost over nearly 10 years, a figure that carried lasting political and social consequences. In Ukraine, comparable losses are now discussed in monthly terms, placing sustained pressure on manpower reserves at a level without recent precedent. This compression of casualties alters the strategic equation. High loss rates force faster mobilization, shorten training cycles, and push less prepared personnel toward the front. Over time, unit cohesion weakens and combat effectiveness declines, even if numerical replacements remain available. The issue is no longer how many soldiers Russia can field, but how quickly quality erodes under continuous strain. This casualty target is considered achievable because it does not depend on rare breakthroughs or large offensives. Instead, it reflects the scalable nature of low-cost UAVs and precision strike systems that can be produced, deployed, and replaced at high tempo. Losses are generated through frequent contact rather than singular events, allowing effects to accumulate steadily. Precision reduces the need for mass. By striking units during movement, coordination, or resupply, Ukrainian forces ensure that even limited engagements contribute to overall attrition. Sustaining this pace requires logistics that differ from traditional models. Ukraine increasingly relies on decentralized production, rapid repair cycles, and flexible delivery methods that avoid large stockpiles near the front, supporting continuous pressure while reducing vulnerability. This system also lowers the operational threshold for sustained pressure. Because UAVs and precision assets do not require large crews or heavy support, Ukraine can apply force more frequently without exhausting frontline units. Small teams can generate effects that once required battalion-level coordination, spreading pressure across time instead of concentrating it into short offensives. As a result, Russian forces are forced to respond constantly rather than prepare deliberately. Defensive adjustments, route changes, and emergency redeployments consume attention and energy even when no attack is underway. Over time, this reactive posture increases mistakes and exposure, feeding back into the attrition cycle Ukraine is deliberately shaping. Within this framework, casualties become a measurable indicator rather than an incidental outcome. Commanders track where losses occur, assess which sectors generate results, and shift assets accordingly, treating attrition as an operational signal rather than background noise. Progress is judged less by territorial change and more by internal trends inside Russian formations. Slower rotations, shorter assaults, and declining coordination signal that pressure is working, even when front lines remain stable. This approach also changes how time is valued on the battlefield. Instead of rushing operations, Ukrainian planners prioritize persistence, because steady pressure produces more reliable outcomes than short bursts of intensity. Each day that Russian units remain exposed without relief increases fatigue and the likelihood of loss during routine activity. Over weeks, these effects accumulate in ways that are difficult to reverse. Replacement units enter the fight with less preparation and weaker cohesion, increasing vulnerability and accelerating further losses. To reach monthly casualty levels at this scale, Ukraine does not need spectacular battles. What it needs, and increasingly maintains, is control over battlefield tempo, now driven primarily by drone warfare. Drone warfare now dominates the entire combat cycle on the Ukrainian battlefield, from early reconnaissance to strike execution and damage assessment. UAVs are no longer used only to spot targets for artillery, but operate as a continuous system that observes, tracks, and reacts in near real time. This allows Ukrainian forces to maintain battlefield awareness even during quiet periods, turning routine movement into usable intelligence. What matters most is persistence rather than reach. Drones remain overhead for long periods, watching how units move, pause, and adjust, which makes patterns visible over time. Once a unit's behavior is understood, pressure can be applied selectively rather than immediately, increasing effectiveness. This constant presence removes the traditional gap between detection and action. When movement is seen early and followed continuously, the battlefield becomes predictable for the observer and increasingly restrictive for anyone attempting to maneuver without being noticed. Because of constant aerial surveillance, Russian infantry assaults are often detected long before they can properly assemble. Units moving toward staging areas are observed while still dispersed, which prevents them from concentrating combat power or choosing favorable timing. By the time an assault group begins coordinated movement, its route, direction, and size are already known. This shifts the point of contact backward. Instead of meeting attacks at the front line, Ukrainian forces disrupt them during preparation through targeted drone strikes, indirect fire, or forced delays. Even small interruptions can break cohesion and push units into premature withdrawal. As a result, many assaults fail without ever reaching Ukrainian positions. The engagement ends before it formally begins, not because of overwhelming firepower, but because early disruption removes momentum and forces Russian units to abort under pressure. UAVs also enable Ukraine to strike critical logistics nodes at moments of maximum impact. Ammo dumps, fuel points, and supply routes are targeted when Russian units are actively pushing forward, not during static periods. Cutting support at this stage prevents follow-on attacks and denies the ability to exploit even limited progress. This dynamic sharply reduces the effectiveness of Russia's meat wave infantry tactics. Massed assaults depend on concealment, momentum, and sustained pressure, but persistent surveillance removes all three. Movement across roads or open ground is detected quickly, while pauses required for coordination expose units to further strikes. The result is high casualty rates without meaningful gains. Repeated losses during preparation and movement make large-scale infantry pushes increasingly costly and less likely to achieve lasting effects. The psychological impact of constant surveillance is as damaging as physical losses. Russian infantry operate under the assumption that they are always being watched, which reshapes behavior at every level. Movement slows, hesitation increases, and direct routes are avoided, reducing tempo and increasing fatigue long before contact occurs. This pressure accumulates during routine activity rather than combat alone. Pauses, regrouping, and basic resupply all carry perceived risk, turning simple tasks into sources of stress. Over time, this erodes confidence and increases mistakes during coordination and movement. Command and control also degrades under these conditions. Communication becomes cautious, coordination fragments, and attacks grow shorter and less synchronized. Tempo increasingly favors the observer rather than the attacker, pushing Russian forces into a reactive posture that reinforces attrition. When airspace control reaches this level, unmanned warfare does not stop above the battlefield, but moves downward, setting the conditions for robots to begin taking over roles on the ground. Ukraine has expanded unmanned warfare from the air down to the ground by deploying unmanned ground vehicles at increasing scale. What began as limited experiments has developed into a structured layer of battlefield capability, where robots operate alongside soldiers or entirely in their place. This shift follows the same logic that made UAVs decisive, reducing human exposure while maintaining pressure in high-risk areas. These systems are not deployed as single-purpose tools. Some UGVs are armed with heavy machine guns and used to engage enemy positions directly, while others focus on transport, resupply, and casualty evacuation. By separating combat and support tasks across different platforms, Ukraine limits the need for personnel to move through exposed terrain. This expansion reflects adaptation rather than innovation for its own sake. As drone surveillance makes ground movement increasingly dangerous, unmanned vehicles provide a way to remain active without paying the human cost that traditional infantry operations would require. One of the most important advantages of unmanned ground vehicles is their ability to maintain presence in areas that are too dangerous for sustained human occupation. Robots can guard approaches, monitor routes, or provide overwatch for long periods without fatigue, fear, or the need for rotation. This allows Ukraine to influence terrain even when infantry cannot safely remain in place. As a result, control of ground is no longer defined by constant physical occupation. Instead, access is denied through observation and rapid response, where approaching forces trigger engagement rather than encountering a static defensive line. Terrain becomes contested because it is watched, not because it is filled with soldiers. This persistence changes the tempo of ground combat. Russian units must assume that even apparently empty areas are covered, which slows movement and increases caution. The ground itself becomes a sensor-driven space, shaped by unmanned systems rather than human presence alone. This shift also complicates Russian planning at the tactical level. Routes that were once considered safe can no longer be trusted, and pauses meant for coordination now carry risk. Units must spend more time checking, waiting, and repositioning, which slows advances and increases exposure. Over time, these frictions drain combat power without requiring constant direct engagement. A significant psychological shift occurred when Russian soldiers surrendered to a Ukrainian combat robot. This moment marked a change in how unmanned systems are perceived, from supporting tools to active threats capable of forcing human decisions. Facing a machine that does not hesitate or retreat alters behavior, especially in confined or exposed environments. UGVs also reduce the cost of prolonged danger. Tasks that would normally require repeated infantry rotations can now be sustained by machines that only need maintenance and reloading. This transfers endurance from soldiers to systems designed to absorb risk. Over time, this substitution effect reshapes frontline organization. Human soldiers remain essential for close combat and complex decisions, but unmanned systems increasingly define when and where that combat occurs. As ground warfare shifts toward control through technology rather than manpower, the enemy is pushed into a reactive posture. However, as both sides rely more heavily on unmanned systems, the contest does not end with deployment alone. It moves toward disrupting, disabling, and destroying these systems at their source, setting the conditions for the next phase of the conflict. Russia has deployed fiber-optic FPV drones to bypass electronic warfare and restore reliability on the battlefield. Unlike radio-controlled UAVs, these drones transmit commands through physical cables, which makes them resistant to jamming and signal disruption. This design allows operators to maintain stable control, even in areas saturated with electronic interference, where traditional drones often fail. The tactical value of fiber-optic FPVs lies in consistency rather than range or payload. They are most effective in short-range, low-altitude attacks where precise steering matters more than speed. For Russian units, this briefly reduced losses caused by jamming and allowed drone strikes to continue in heavily contested zones. However, this advantage also introduced new constraints. Fiber-optic systems require careful cable routing, protected launch points, and predictable flight paths, which limits flexibility and increases logistical burden at the tactical level. Ukraine responded by shifting counter-UAV efforts away from the drone itself and toward its control mechanism. Instead of trying to intercept fiber-optic FPVs in flight, Ukrainian forces began using unmanned ground vehicles to locate and sever the guiding cables. This approach targets the most vulnerable physical component of an otherwise resilient system. Ground robots are well suited for this mission because they can operate close to flight paths without exposing soldiers. They move through rubble, vegetation, and trench networks where fiber optic lines are laid, cutting or damaging the cable directly. Once the connection is broken, the drone immediately loses control and becomes ineffective. By attacking the control link, Ukraine neutralizes the core advantage of fiber optic FPVs. A system designed to resist electronic attack proves fragile when confronted with physical disruption, collapsing the claim that these drones are unjammable in real combat conditions. This exchange illustrates a broader shift towards system-level warfare. Rather than focusing on destroying individual weapons, Ukrainian forces aim to disrupt the networks that allow those weapons to function. Command, control, and connectivity become primary targets because breaking one link can disable multiple assets at once. The UAV versus counter-UAV contest also accelerates costs and complexity. Fiber optic drones demand more preparation, more protection, and tighter coordination, which slows deployment and reduces adaptability. As countermeasures improve, the operational payoff of these systems declines. This pressure reshapes how units plan and deploy drone assets. Launch teams must operate closer to protected areas. Cables must be concealed and guarded, and recovery becomes harder once lines are exposed. Each additional safeguard consumes manpower and time, reducing the efficiency that fiber optic FPVs were meant to provide. In this environment, advantage becomes temporary. Each innovation triggers a rapid response, forcing both sides into continuous adaptation. The battlefield increasingly rewards those who can disrupt processes rather than platforms. This dynamic also shortens the lifespan of any single advantage, because systems that require protection and preparation lose value faster under constant pressure and rapid battlefield adaptation. Alongside these technological battles, Ukraine is also reshaping how it organizes and sustains warfare, pointing toward a new model where combat results are directly linked to supply, incentives, and rapid reinforcement. Ukraine has introduced the Army of Drones bonus system, effectively turning the battlefield into a performance-based ecosystem. Instead of relying only on traditional command-driven allocation, this model links battlefield outcomes directly to incentives, allowing effectiveness to be measured and rewarded in near real time. The focus is not spectacle, but speed, accuracy, and sustained impact. Under this system, concrete actions are converted into points with clear values. Eliminating enemy soldiers, capturing prisoners, and destroying equipment each generate specific scores, removing ambiguity about what counts as success. This clarity pushes units to focus on actions that directly weaken the enemy rather than symbolic achievements. Points earned in combat can then be exchanged for new equipment through a decentralized process. Units use their scores to acquire UAVs, sensors, ground robots, and related tools directly from manufacturers. This shortens procurement cycles and reduces dependence on slow, centralized supply chains. The result is a closed operational loop. Combat performance leads to faster resupply, which enables further action, reinforcing effective tactics without requiring large administrative intervention. Resources flow toward results, improving efficiency without expanding force size. The system also changes behavior at the tactical level. Small teams are encouraged to act independently, seek opportunities, and adapt quickly, knowing that results translate into tangible support. Initiative becomes valuable, while hesitation carries a cost, pushing operations toward faster decision-making. Importantly, the Army of Drones bonus does not remove command authority. Senior leadership still defines priorities and limits, but execution within those boundaries becomes more flexible. This balance allows innovation while maintaining overall coordination and strategic direction. Over time, this approach reshapes the meaning of mass in warfare. Advantage no longer depends on how many soldiers are deployed, but on how quickly a force can observe, strike, assess, and rearm. Speed and efficiency become strategic assets in a battle space dominated by unmanned systems. For Russia, this creates a structural disadvantage. A force built around centralized control and slower logistics struggles to match an opponent that rewards rapid adaptation and decentralized action. Even when manpower is available, turning it into sustained pressure becomes harder. Taken together, the Army of Drones bonus system reinforces the broader transformation already visible across the battlefield. Technology, incentives, and organization are merging into a single operational framework, pointing toward a new model of war with increasingly clear strategic consequences for Russia. This feedback loop compresses learning cycles, amplifies successful tactics, and widens the performance gap between adaptive units and slower formations. The war in Ukraine reveals a new model of warfare defined by high attrition and the expanding role of machines. Combat is no longer driven mainly by mass troops or dramatic breakthroughs, but by systems that apply constant pressure through surveillance, precision, and endurance. This shift changes how battles are fought and how outcomes are measured. Beyond Ukraine, this battlefield is shaping how future wars will be fought. Control, speed, and systems integration are becoming more decisive than numbers alone, setting a precedent that other militaries are already studying closely. If this analysis helped you better understand how modern wars are fought and why their costs keep rising, consider subscribing to Military Force. This channel focuses on explaining conflict clearly and responsibly, not to promote war, but to understand its impact and consequences. Knowledge is essential for informed discussion, and informed discussion is one step closer to lasting peace.